As we saw together, if your system is a type 1, type 2, type 3, you should think about the order, remove the pole in the origin part, and consider about the 4 region in the contour A. Then you can plot the nyquist. Region 1 is here, epsilon E j theta. Now region 2 is S, go to the j omega that we did for all. Region 3, the big circle is here, is R E j phi. Normally this the all the time magnitude will be 0 and the phase will be 0. Region number 4, S equal to minus j omega, and you can draw the nyquist in the 4 regions. Here is if equal to type 2, you have a 2 pole in the origin part, and you can eliminate this one the same as the type 1. Here they give the example. They said they drew the nyquist. It's not difficult. Here you first of all you can check the system is a first order or second order. You can say it's a standard form or not. This is not the standard form. You change to the standard form. And here if you see you cannot change to the standard form. How can I solve such as this example? Here you cannot check the standard form easily. You go to the step 2. You put the S equal to j omega. In the denominator become 10 j omega minus 1, and the denominator you can write the S2 plus 5s plus 6, and you put the j omega here become minus omega 2 plus 5 j omega plus 6. You separate the imaginary and the real. If you have a system something like this, A and the denominator you have the, here you have for example 10a plus bg. If you want to separate the imaginary and the real, all the time this one will be multiplied the conjugate of the denominator minus bg. Here become 10a minus 10bj, and the denominator become a2 plus b2. 10a divided by a2 plus b2 become real, minus 10b a2 plus b2 become imaginary. And easily you can write the magnitude. Magnitude will be root of the real power 2 plus imaginary power 2, and the phase will be arctangent imaginary divided by the real. Only you should consider you are in the which quarter of the system. If you are in the quarter both of them positive, you don't need to worry. If you are in the quarter 2, here you should 180 degree. If you are in the quarter number 3 and quarter number 4, you should consider you are in the which quarter. Then you can find the magnitude and the phase, and with the different omega you have a different magnitude and you have different phase, and easily you can do the nyquist, and you can check the nyquist circle how many cycle around minus 1. You can calculate the n. Then you can say you can find the z based on the the p. The p is a pole in the open loop of the system. If the z is equal to the 0, your system is stable. If z is not equal to the 0, your system will not stable. Okay. For the drawing the nyquist, I will stop here. I will go to find the phase margin and the gain margin of the Nyquist.